Okay, everyone, scientific notation. This is just going to be front back. There's not going to be a packet to do today. And as far as exponents go, this is what we struggled with most on the quizzes was the scientific notation because we didn't do a lot of it last year. So if it's felt like the last couple of days have been a lot of review and you know everything, make sure that you listen to this video closely because this one does get a little more complicated. So scientific notation is just a way to express really big or small numbers. Okay, so I think basic scientific notation we probably get, but it's some of the other stuff when we're multiplying them together and dividing and stuff that it gets a little more complicated. The minimum distance from Earth to Mars is 284,000 miles, right, in scientific notation. Okay, the whole thing with scientific notation is that you have to rewrite the number between 1 and 10. So what I mean is this times 10. If it's a big number, you're going to have a positive exponent, and if it's a small number, it'll be negative. This is a big number. So we count how many places we move the decimal place, which this was 5. So 2.84 times 10 to the 5th. Example 2 would be a small number. In 2004, the Indonesian earthquake slowed the rotation of the Earth, making the length of a day barely any shorter. Write the number in scientific notation. So we have to write it in between 1 and 10. So this would be 2.68 times 10. And then we have to count how many places we moved the decimal. So we moved that from here to here, which is 1, 2, 3, 4, 5, 6 places. But it's a small number, so it's negative 6 places. Okay, so that is the basic scientific notation, which is going to let you just fly through these first ones, okay? Now, adding and subtracting is the toughest. It's actually harder than multiplying and dividing, so listen closely. Step 1, make sure the exponents are the same. They call it LARS in the notes, and actually don't explain it at all. I can tell you how to do it, and maybe after I show you how to do it, you can figure out what this whole LARS thing is, but I would rather just kind of solve the problem. So basically, all you need to know out of this is that the exponents have to be the same. And then step 2, add and subtract the numbers and keep the common exponent. So with adding and subtracting, and only with adding and subtracting, the exponents have to be the same, okay? So with nice ones like number 13, it's real easy. I'm like, they're both 10 to the second. Well, then I can go 3.4 plus 5.2, and I can get 8.6 times 10 to the second. Just that easy, okay? Now, let's take one like number 14, where they're not both the same, okay? So that means that we have to shift so that they are both the same. So they either need to be both 10 to the 7th, or they need to be both 10 to the 6th. So I start thinking about, okay, well, if I wanted to make this, and listen close to this part, this is the toughest part of today. If I wanted to make this 10 to the 6th power, if I wanted to make this smaller, I would need to make this bigger, right? I would need to make this 95. And 95 plus 1.1, that's a little bit bigger than in between 1 and 10. So it's not 10 to the 7th that I want to modify. So then I bop on over to the other one. I'm like, okay, well, let's take 10 to the 6th and make it 10 to the 7th. So if I were to make this 10 to the 7th, I made that bigger, which means I would need to make this one smaller. So what this really becomes is 0.11 times 10 to the 7th plus this stuff. So now I add the two of them together, and that would give me 9.5 plus 0.11 would be 9.61 9.61 times 10 to the 7th power. And what we did right there was we just made sure the exponents are the same, and then we add, subtract the numbers, and we kept our common exponent. Okay? All right, let's do just a couple more on this page, okay? So let's look at 15. So we have -4 and -5. So I'm thinking, okay, if I made this -5, I'd be making that smaller, and I would need to make this 72. Oh, too big. No good, okay? So if I'm doing that, that means that I need to make this -5. We need to make it -4. So if I were to increase this to -4, I would have to decrease this to 0.318 times 10 to the -4th, and then I would have to go 7.24 plus 0.318, which is, that's just a weird thing to add, is 7.558 times 10 to the -4th. And sure enough, always check and make sure that this answer is in between 1 and 10 when you guys are done, okay? So I'm thinking now, when it says use the LARS, which is left add, right subtract, what could that possibly mean? Well, in both of these addition problems, we changed the one on the right. So I'm not sure if that has anything to do with anything or not. You might be able to figure that out as you go along and you practice just a few more of these. Let's do a subtraction one. So for my subtraction, those are both 10 to the 4th. That's easy. Those are the same. Here we go. Here's one that's different. 21. So if I were to, I just think if I drop this to 11, this would increase to 50 to make it equivalent. If I were to increase this to 12, this would have to drop to 0.9 times 10 to the 12th. And now I have a subtraction problem where I go 5 minus 0.9, and I have 4.1 times 10 to the 12th power, okay? So that should get you through those. Again, the adding and subtracting is going to be some of the more difficult stuff. The multiplying and dividing, we really had a problem with on the quizzes because we must not have done it last year. So step 1, multiply and divide the numbers. Use the product and quotient rule to change the exponent, and use, I guess you can write LARS, maybe we'll eventually figure out what that is. Left add, right subtract, to adjust the decimal and exponent in the final answer as needed. Okay, here's how easy this is. So for this one, all you have to do if you're multiplying is go this times this and then this times this. Okay, so 2.8 times 1.9 is 5.32 times 10 to the, well, what's 10 to the 7th times 10 to the 4th? We have to use the rule that we used the other day where we add the exponents, okay? All right, let's do one that's going to be a little trickier, like 27. So we're going to go 3.4 times 8.5. And I'm going to get 28.9 times 10. And then I have to go this times this, which requires adding the exponents. Now, you put that on a test, it's going to be incorrect because the first number is not in between 1 and 10. So I need to make that 2.89 times 10 to the, now I just kind of use common sense. Did I make this bigger or smaller? I made it smaller, which means I have to make this bigger. Hopefully that made sense. If it didn't, you'll pick it up with division. Division, so same thing, that number's got to be in between, it's got to be in between 1 and 10. So let's do 31 because I can tell that one's not going to come out between 1 and 10. So all I have to do is divide those two and divide those two. So 1.2 divided by 5 is 0.24 times 10. And then what's 10 to the negative 5th over 10 to the negative 6th? Well, that's just what we did the other day. We would have to go negative 5 minus a minus 6, which is negative 5 plus 6, which is 1. Now, this number here is not in between 1 and 10. So I need to move the decimal and make it 2.4 times 10 to the, well, I made this bigger, so I need to make this smaller. And that would be times 10 to the 0, which of course is just 1. So really the answer to this problem is 2.4. Okay, hopefully that made sense. There will be some quizzes when you guys are finished today. So just kind of work on those a little bit, and I'm anticipating that you guys will all finish this and file it before the end of the period, and I will be seeing you on Monday.